So in this problem, we're asked for the integral, or the area under the curve, from 1 to 4. And we've been given pieces from 0 to 1 and from 0 to 4. So this 1 to 4 is really a part of the entire thing. That from 0 to 4 is our entire area. So if I were to think about this, I've really got two parts. I've got some area from 0 to 1, and another area from 1 to 4. We'll call this area 2 and area 1. And area 1 plus area 2 make the entire integral from 0 to 4. And so I'm going to set it up just like this. We've got something plus something equals the total. And the total, they've told us, is -3 because that's from 0 to 4. The first part, from 0 to 1, is 2. The second part, from 1 to 4, we're not sure what that is, but we know the total from 0 to 4 has to be that -3. So if I thought of this just as kind of an algebraic equation, if I was solving for the question mark, I could subtract 2 from both sides. This missing area is -5. That's this portion right here, the integral from 1 to 4 of f of x dx. That's -5. That's this part right here. So if I was to split this up, I'm going to take this integral right here from 1 to 4, 3 f of x plus 2 dx, and I'm going to apply some rules to this. I'm going to factor out that constant. So we really have 3 times the integral from 1 to 4 of f of x dx plus the integral of 2 dx from 1 to 4. But I know that I found this portion to be -5. So when I multiply 3 times the integral from 1 to 4 of f of x dx, then we really just have 3 times -5. This portion, this first portion, is -15. The second portion is again back to this area model. I've got a y-coordinate of 2, and I'm looking at it from 1 over here to 4. Well, that really just means I have a height of 2 and a base of 3. That area is 6. So if I think about combining these two integrals, -15 plus 6 is -9.